Oh, hi. Monaco here. I'm coming to you with your first pre-lab video. In this pre-lab, we are going to go through the procedures and the parts of your density lab, and I'm going to show you how to collect your data, do your calculations, and complete your first comprehensive lab report in my class. So stay tuned for the background purpose procedure, and here we go. So the lab that you need is the density lab paperwork. It looks like this. It's got our boot camp logo up here, calls it density, and you'll notice big blank chunks. That's what this pre-lab is all about. Getting the blanks out so you know what you have to do in the lab on lab day. So here it is, our background information. Density is a physical property of matter. So it's kind of unique and can be used to identify what type of matter something is made of. The density equation is D equals M over V. Do want to define the variables there. D, density, has the units grams per milliliter, and the mass of G's grams, volume is in milliliters. We're going to perform a percent error calculation at the end of this to see how close your results were to what you should have gotten. Okay, so that's your equation. You can also find that on table T. And here's the purpose of this overall lab. We need to identify what element an unknown sample is made of by measuring and comparing its density to known materials. Okay, so get ready for part one. So in part one of this lab, we're going to find the density of some regularly shaped solids. Regularly shaped are things that have straight edges. So like this cube, and this, well, rectangular prism. To find your object's mass, you will put it directly on the scale, okay? And you want to describe your object with what it is. I would write red rectangular block, white plastic cube with the number 8, silver metal cube. Those are my object numbers or descriptions. To find the masses, as mentioned, you'll just put them on the scale. Then you have to do length, width, and height to figure out the volume, because remember, the volume is length times width times height. So for your procedures, 1, pick 3 objects. 2, mass the objects. 3, find their volume by length times width times height. 4, calculate the density with the equation. When you're doing length times width times height, you have got to use our centimeters. And make sure you line it up properly. Don't use the edge of the ruler. You're going to be inaccurate. You want to line it up so you're measuring the length of it in centimeters. This one appears to be about 6 centimeters. So that would be my length. I'd write it down. I'd do my width and height. I'd calculate the volume by multiplying the 3. Then I'd divide it by the mass to get the density. So you're going to figure out the density of 3 objects. Is it going to be exactly these 3 objects? No. You can pick any 3 regularly shaped objects from our selection. Maybe you should avoid these ones. Unless you're really good at geometry, you can figure out the volume in a complex way. But there you go. Stay tuned for part 2, where we're going to do irregularly shaped objects. All right, we're getting ready to do part 2 of our density lab, irregularly shaped objects. For this particular part, we are just going to be using marbles. Black marbles, red marbles. And we have to do volume by displacement here. So the first part of the procedure is get a black marble, get a red marble. Second part of the procedure, got to use a graduated cylinder to figure out the initial volume. So I suggest setting your graduated cylinder to about, oops, I missed, 10 milliliters. Okay, remember you got to get down low, read the meniscus, set it to about 10 milliliters as your initial volume. A little swishy swish. That's just about perfect 10 milliliters. So your initial volumes is what volume you start with without the marble in there. And the final volume is the volume that it rises to once you've added your marble. So you got your marble color red. Obviously you can find the mass of it very easily. You put it on the scale. It might roll around a little bit, but as long as it's on the scale, it'll stay. Not all marbles will weigh this much, so weigh your own. Then you figure out the volume by displacement. The final volume is whatever it may have rose to. So you take your second measurement, oops, marble on the run, and you subtract. So it looks to me about, 10, 11, 11.8 milliliters minus 10, so about 1.8 milliliters was my total volume here. You're probably going to get a different result, so be careful. To find the density, again, density equals mass divided by volume. So you take this number, divide it by the total volume number, and you get your density value. So recap the procedures. 1, get your marbles. 2, find their masses. 3, find their volumes by displacement. 4, calculate density. Okay, so that's irregularly shaped objects. Stay tuned for the unknown. All right, part 3. Identifying an unknown substance. Remember, this is the purpose of the lab. Identify what element an unknown sample is made of. The first 2 parts of the lab were to get you to figure out how to find mass, volume, density, all that stuff of some objects. You're going to need those techniques to get through part 3. This is the unknown. Looks shiny silver-like, but what element is it? We'll use the density value to find out. So notice you'll probably have to find the volume of these things using displacement. Okay, they're not regularly shaped. So you'll have to find the volume through displacement. The mass, make sure you mass them before you find their volume. You don't want to be massing the water. And I suggest when you do your unknown to get a few pellets, not just 1 or 2. The volume might be too small to measure. So get a few pellets, a small pinch, let's say, to do the mass and volume on. You'll calculate the density in the same way. Mass divided by volume. You'll find this volume by doing the irregularly shaped object technique. Okay? And then you will have a measured average density of the unknown metal. Measured average means I need you to do it 3 times. 1, 2, 3. Not everybody's accurate the first time, second time. So if you average 3 results of density, you'll get a really good number to use, which will compare to these values. It might not be exactly which one of these, but it will be closest to one of them, and you can make an educated estimation that you believe that your unknown metal is most likely 1, 2, 3, or 4. Okay? After you finish that unknown estimation, there's a little bit of a simulation to understand density. You can get a computer in my class or try this one out at home. It's an HTML page, and it is all about a simulation dealing with density and buoyancy. Okay? These instructions are kind of like Pogel's instructions, where it tells you what to do and how to do it each step of the way. The last part to get full credit for the lab is to restate the purpose, to make a claim about what the identity of your unknown was. So back to that particular I believe that portion. Take the data to cite your specific test results. You got to support your claim. So measure data, etc. Percent error. So this is going to be a calculation based upon what you should have gotten. You can check with me, the teacher. I'll tell you what you should have gotten for your average density of the unknown. You do a percent error to see how close you were. Last, you do an interpretation, which is to fill out the sentences to basically build up a paragraph that supports your work on this particular lab. So let me just recap for you in a minute. That was a lot. I know I talk fast, but the good thing about doing pre-labs this way is you can pause, rewind, fast forward, rewatch, and do whatever you have to do in order to get a good understanding. Remember, I need you to watch this video, fill out the notes portions of the packet, and be able to tell me what you have to do in the lab before you can actually do this lab in class. I do it this way for many reasons, so that you can get access on your own time, and so that you are educated about what to do in the lab before you do it, so that you have more success in my course and college courses that you may eventually take on science and engineering and technology. So I hope that you enjoyed this. Please give me feedback and let me know if I can do anything to make this better. See you later.